Okay, we're going to take a look at inequalities. Now, I realize this is something, again, that you have seen before, worked with before. This is nothing new for you. You know what a less than looks like, a greater than looks like, less than or equal to, greater than or equal to. Now, again, if you have problems remembering that, make sure you put that kind of stuff into your little book. Makes life easier. Now, properties of inequalities. Again, this is nothing new. We've seen this before, and it works exactly the same way. Yeah. Yeah. The only catch, and it is the only catch, whenever you multiply or divide by a negative number, what do you got to do? Anybody remember? Multiply or divide by a negative. What do you got to do with the inequality? Switch it around. Goes from less than to greater than, or greater than to less than. That's the only catch that you have to worry about. Okay? Now, there is something new that I want to show you. This is coming out in a lot of the newer textbooks, ACT tests, PSAT tests, and those type of things. They're not going to have the little open circle there or the closed circle. They may or may not, but more often than not, you are going to see something that is listed like this. This would actually be done with a parenthesis facing that way. This would be done with a parenthesis facing this way. This would be a bracket facing this way. This would be a bracket facing that way. Now, the only thing that I have ever been able to figure out when I've talked to other people about this is that on the keyboard there's no open circle or closed circle. So it identifies and makes life a lot easier for actually typing this in. So like this one here where it says x would be greater than 1, what we would end up having there, that would be looking like this. You'd have a parenthesis, you'd have a 1, comma, and you'd see it listed as infinity and a parenthesis behind. Okay? Something new that I definitely want you to be able to at least recognize. For this one over here, it would be negative infinity, and then, that would be, get off of that. Don't know about that some days. Comma. Gotcha. There it goes. Comma 1. Parenthesis. These down here, this would be bracket 1, comma, infinity with a parenthesis. Over here you would see it as negative infinity, comma, 1 with a bracket. Now, this is just an FYI. Parentheses are always going to be used whenever we're dealing with infinity, because bracket means that we know exactly where it's at. It is at 1. Does anybody know what the number for infinity is? Yeah, there is no number that you can identify that, right? Because I mean, if you can identify that number, you can always add 1 to it and get a bigger number, right? So that's why infinity cannot be identified. That's why it's going to be a parenthesis around it, because it's coming close to it, but it never quite gets there. It's just the notation that you've got. I don't want you to come to the MCA tests, ACT tests, and whatever else tests that you end up having to deal with and be messed up with the notation. So, give you a few moments, make sure that you've got that kind of written down so that you can see the differences between them. So, solving inequalities using properties. Again, this is nothing any different. I know it's kind of like a redundant saying here, but you guys know how to go through and solve these things. So if I see t plus 6 less than 7, subtract 6 to both sides, subtract 6, and we end up with t less than 1 when we graph it. All I would expect you to do for a graph, you put this, identify it at 1. You don't have to go and put all the other marks in there. What would be at 1? Open circle or closed circle? Well, is 1 included with it? Is it equal to 1? If it's not equal to 1, you can't do it. It's just going to be an open circle. A very wise student of mine many years ago came up with this idea that, well, if it's got the little line underneath it, then I have to fill in the circle. If it doesn't have the little line underneath it, then I don't fill in the circle. Okay. So, I take a look at B. Do pretty much the same thing again in that, okay, what I'm going to do here, you guys might think it's kind of on the crazy side. You see distributed property there right away, don't you? Well, I got a number here, I got a number over here. So is it possible just to go and divide both sides right away by, divide both things right away by -2. So I got it here, number there. So what I would do is divide this side by -2, divide that side by -2. So I am just left with 4 plus b and -2. But since I divided by a -2, what must I do with the inequality? Flip it around. So instead of it being a less than or equal to, it will now be a greater than or equal to. Okay? Subtract 4, and I end up with b greater than or equal to -8. So if I graph this out, okay, it's going to be at -8, and what would I put? Open circle or closed circle? Well, it's got the little line underneath it, so it's going to be a closed circle. Now, I've got the differences down on that. Now I've got to identify where I should shade. Am I going to be using numbers larger than or smaller than? So if I look at the first one up here, it was said t was less than 1. So am I saying that any number that's less than 1 should work? Okay. So that means it gets shaded in going down this way. Let's check. Give me a number that is less than 1. -1. If I put -1 in for t, so if I put in -1 plus 6 less than 7. Well, -1 plus 6 is 5. Is 5 less than 7? So it's true. It works. I shaded it the right way. Now, the other one. Which way is it going to get shaded? Well, b has to be greater than -8. So that means that it's going to have to be values that are up this way. So, give me a value that's larger than -8. -4. So if I were to go put -4 in here, so that would be -2 multiplied by 4 plus -4. Is that less than 4? Well, let's see. 4 plus -4 is 0. What's 0 times -2? So is 0 less than or equal to 4? And that's true. So it did work. We were able to identify the values that were going from there. So, if you've got to go through and graph these things, this is all that I would expect for you to do. Draw it out like that. Draw it out like this. You don't necessarily, like I said, need all the other little numbers in there. Identify where you're at, open circle, closed circle, which way are you shading, up or down. Let's take a look at this. Now, we need to go and solve each inequality first. So with this one, a little bit more complicated. I've got the -2 I've got x plus 3 less than negative 2x plus 1. Well, I'm going to have to use the distributive property this time because I got variables on both sides. Negative 2x minus 6 less than negative 2x plus 1. Now, when we were solving things before, I had said that it doesn't matter whether the x is on the left or on the right side. That was because we were dealing with equality. Doesn't matter. When we work with this, always try and get the variable off onto the left side. Doesn't matter whether it's positive or negative, just move it over there. So, if I go and add 2x to both sides, I add 2x, add 6, add 6. So I get negative 2x plus 2x. They disappear, don't they? Negative 6, positive 6. That disappears, so I end up with what over here? 0. Less than. Negative 2x, positive 2x. That disappears. Positive 1 plus 6, I get 7. Is that possible? Is 0 less than 7? Yes. So, how in the world do I graph this thing? I don't have any x's left, do I? Well, what happens here is this is always true. It does not matter what number you pick, you plug in there, it'll always be true. So somebody give me a number that they think won't work. 10? Well, let's see. If I put 10 in here, what's 10 plus 3? 13. What's 13 times negative 2? Well, that would be negative 26. I put 10 in over here. What is negative 2 times 10? Well, that's negative 20. What's negative 20 plus 1? Negative 19. Is that going to work? Is negative 26 less than negative 19? Yeah, that's correct. It does not matter when this comes up, it's always going to be true, no matter what number you pick. Okay? Let's take a look at the next one. So I've got 4b less than 3 plus 4 multiplied by b minus 1. 4b less than 3, 4b minus 4. Use the distributive property there. And I've got 4b less than, oops, hold a sec. 3 plus negative 4 gives me a 1 plus 4b. Subtract 4b to both sides, subtract 4b, and I end up with 0 less than 1. Is that true? So does this always have to be true? Yeah, it's just another situation that this is going to be always true. Now, what would happen if this turned out and didn't work this way? What happens if I got something that was definitely false? Would it always be false? If I do this, I get something that's always true, it's always true. If I do the algebra and I get something that is not true, it's always not true. Okay. So it's not that big of a deal, but it's something that you need to be aware of. If you get things like this, variables disappeared, always true. So that one's always true as well. So, here we go. Compound inequalities. Two things at one time. If I look at this one here, and, okay, both conditions must be true. So I'm going to go through and solve this one. I'm going to add 10 to both sides, add 10. I've got 4x greater than or equal to, and then I end up with, that's going to be 8. So, divide by 4, divide by 4, x is going to be greater than or equal to 2. Okay? That's what happens there. Over here, add 10, So I end up with 4x is less than or equal to 20. Divide by 4, divide by 4, x is less than or equal to 5. Now, is it possible for this to be true? Is it possible to have a value that is greater than 2 but less than 5? And the answer would be yes. One of the ways that we can go and write this out for ourselves, do this, 2 would be here, 5 would be here, correct? What do I put at 2, open circle or closed circle? Shaded underneath it or line underneath it, so it's shaded in. What would be at 5? Same thing. Now, because it says and, both conditions must be met. What's going to be bigger than 2 and less than 5? Well, that's going to be just this area right in here. That's all the graph is. Okay? Like I said, nothing new, nothing you haven't seen before. Okay. Let's take a look at B and see how that one goes. Okay. So, work this one out. Subtract 1, subtract 1 means I've got 2x is going to be less than 2. Divide both sides by 2, divide both sides by 2. X is going to be less than 1. So that's the first one. Add 6, add 6. So I end up with 3x is greater than 12. Divide by 3, divide by 3. X is greater than 4. Now, I have an OR. If I have an OR situation, does that mean both of them have to be part of it? Or just one or the other? Okay, you have a choice here. So when this graphs out, I got it at 1 and I've got it at 4. Okay, I asked the question, what do I put it for? Open circle or closed circle? So open circle, open circle. Okay. Which way should I shade? Well, I want things that are less than 1. So that means I would have to go down this way. I want things bigger than 4, which means that I would have to shade up this way. So, my question is it possible for me to have this? Is it possible for me to identify a number that is less than 1 or bigger than 4? Yeah, and that's the truth. I can get by with that. Now, if this would have had an and in it, I can't do it, because I can't have a number that is both less than 4 and bigger, or less than 1 and bigger than 4. Not possible, is it? So, like I said, this is just review. You guys have seen this before. So, what I'm going to do here is I'm going to give you, I'll give you a minute and do A. So for this one, I've got 3y plus 2 greater than 8, subtract 2, and I end up with 3y greater than 6. Divide by 3, and I get y greater than 2. So, I put the graph down here at 2, open circle, shade it up that way. Am I right? Okay. Good. Okay. Give you another minute, do the next one. Alrighty. So, got this. You agree? Okay. I got a fraction. Is that even possible? Well, yeah. Just because you get a number that isn't a fraction, when you're doing these problems, doesn't mean it's wrong. Although, because experience tells us that we usually get nice whole numbers, let's double check. So I got 10. That's going to be 2. Nothing to go on over there. Add a gives me 3. Subtract 10. Ooh, that should be a negative there. And a negative there. That's the only thing I missed. Now, if I add or subtract a negative, do I have to worry about flipping the sign? And the answer would be no. So, what's the graph for this one going to look like? Well, the graph for this one would simply be that, put the number. What am I at? Negative 5/3. Open circle, close circle, open. Oh, yeah, you're right. Missed that. Yep, closed. Which way am I going to shade? Down. Okay. And the thing is, don't get into the habit of doing things too quickly. Otherwise, you end up making more mistakes. And that's what I was doing there. So, give you another minute and have at the next one. next one here. So for C, I've got 4, parenthesis, x minus 1, greater than 4x plus 3, 4x minus 4, subtract 4x, subtract 4x, add 4, add 4, and I end up with cancels out, 0 is greater than 7. Oh. 0 is greater than 7 is always true? Other way around, right? Yeah. Could this ever be true? No. Can never be true. Can I graph it? I can't graph this thing, so this would just be always false. Nothing I can do with it. Okay? Or if you want, you can just draw a line through this, saying that it's not greater than or equal to, although that does imply that it is less than or equal to. But we're not going to go there. Okay? So, alrighty. I'm going to give you another minute, and I want you to do E. We'll skip D. Not that big of a deal. Nothing more that we haven't done, but I want you to do E right away. Because that one's a little bit on the trickier side. You've done these before, so don't freak out. Now you're looking at this one and going, what? Yeah, pretty much. Because you get 8 less than or equal to 5x plus 3 is less than or equal to 23. Now, easy, David, easy. Let's see if this is going to work the way I want it to. Nope, not yet. Let's see. Properties. Fill. Okay. Now, this looks crazy right now. But if I were to go and do that, would you know exactly what to do? Yeah. That's not a problem with that, because what you'd end up doing is you would subtract 3 here, subtract 3 here. Now, what happens if all you seen was this stuff? Well, you'd subtract 3 here, and you would subtract 3 here, right? It's exactly what you do to solve this. Okay? So, it's basically making sure that we keep everything in order. If I do one thing to the middle, I got to do one next, same thing to the left, same things to the right. So what we end up with on here is going to be, this is going to be 3, or correction 5, less than or equal to 5x, less than or equal to 20. So, if I was able to divide everything there, or subtract everything by 3, could I divide everything by 5? Perfectly legal. Divide by 5, divide by 5, divide by 5. So that means now I have 1 less than or equal to x less than or equal to 4. And you're probably looking at this and wondering, well, geez, how in the world do I even think about graphing this? This is easy. Draw the line underneath it. With that there. What number's here? 1. What number's here? 4. Where's x? Between it. What do I put at 1? Open circle or closed? Closed. What do I put at 4? Closed, and X is between it. Shaded right there. This is the only time you're going to see the X between two things like this.